Last week, Tesla held its long-awaited Battery Day, and during that event, Tesla told us about the massive improvements it was planning to make to every single part of its battery cell production process, from raw materials to finished battery cells, all of which will ultimately reduce the cost of producing electric vehicle-grade batteries by a cumulative 69% per gigawatt hour. Some of these improvements relates to cost savings in the production process, like switching away from the 18650 and 2170 cells that Tesla currently uses and moving towards a larger 4680 form factor tabless cylindrical cell. As a side, I want to apologise for saying 4860 a few times in the last week. While my math skills are normally pretty good, my ability to read numbers out is less than subpar, so please forgive me for getting the size wrong. The correct size is 4680, 46 millimeters in diameter and 80 millimeters tall. Anyway, back to Tesla's Battery Day. During the event, in addition to those new 4680 cells, which by the way Elon Musk confirmed yesterday have been powering a test fleet of Teslas for many months, Tesla's team talked about the new silicon-based anode design of future battery cells. Silicon is an element that is in great abundance and should help reduce the cost of cell production. We also heard about a new high-energy nickel cathode, the exact compound of which would change depending on the application that the battery was to be used in. Then there was the dry electrode coating process that Tesla has refined since acquiring it as part of acquiring Maxwell Technologies last year. And then there was details of the super-fast, fully automated cell production line machine, which takes raw materials at one end and spits out fully finished cells at the other. I'm not going to go into any of these today, although I know that some of you have expressed interest in me doing so, and I'm hoping that we can set up another collab with Dr. Ewan McTurk from Plug Life TV to discuss this in more detail, because he really knows about batteries. Some of the other Battery Day announcements related to the sourcing of raw materials for Tesla's future battery supply, namely a push from Tesla to source all of its raw battery materials in the US for its US-made cars. This would not only sidestep the issue of ethical mining in Africa — Tesla is also shifting away from cobalt in its cells anyway — but it would also help Tesla save money on shipping, not to mention have a positive impact on US jobs. During the Battery Day presentation, we were told that the state of Nevada has enough lithium to turn the entire US transportation fleet electric, and Tesla is looking to utilize a saline extraction method to remove lithium from clay deposits in Nevada before then redepositing the clay where it came from, just without the lithium. If you heard that too, then you might have been curious earlier today when it was announced that Australian mining firm Piedmont Lithium has signed a 5-year deal with Tesla to supply it with lithium ore for use in its future battery packs. So today we're going to examine the deal, explain why it's important for Tesla, and why it's likely to help Tesla ensure that it can continue to produce high volumes of both static and automotive-grade battery packs for many years to come. First, let's clear something up. While Piedmont Lithium is an Australian firm, it's actually got operations in several countries, and in the last few years, it's been readying its own mining operations in North Carolina. That mine, located in the North Carolina Tin Spodumene Belt, which is about 40 kilometers or 25 miles west of Charlotte, North Carolina, is currently the only lithium mine of its type in the United States. The area it is based in is considered by geologists and mining experts as being one of the best and largest natural lithium deposits in the world. In this case, the lithium is found inside pegmatite deposits that are found throughout the area. Pegmatite, in case you were wondering, is an igneous rock formation that forms towards the end of the crystallization process of magma, and is known for containing some pretty big hulking crystals in it. It also includes spodumene and beryl, which are two ores which can be refined into lithium and beryllium respectively. However, I'm not a geologist, so if I have got any of that wrong, please let me know below. Piedmont first looked at building a mine in 2017, and it's been working on that mine since. The deal signed today is the first official deal that it's signed off of its mining activities at that new North Carolina facility. According to the press release announcing the news, the deal is a 5-year fixed-price binding purchase commitment, or rather, a 5 years from the point of delivery of the first batch of lithium spodumene concentrate from the facility, and has the possibility to be extended a further 5 years subject to agreement from both parties. It represents approximately 1/3 of the planned annual production from the new Piedmont facility, which is equivalent to 160,000 metric tons of SC6 per year. That's tons spelt TONNES, not either the US short ton or the British long ton. And I'm noting this because some outlets have incorrectly changed the unit of measurement in their reporting, and a British ton, TON, is 2,240 pounds, a US short ton, TON, is 2,000 pounds, and a metric ton, or TONNE, is 1,000 kilograms or 2,204 pounds. That difference may not seem like much, but when you're talking about several 100,000 of them, it's a pretty big deal. Oh, and by the way, SC6 is shorthand for lithium spodumene concentrate with a 6% lithium oxide. It's the standard exported concentrate for most lithium processing facilities around the world. I should note too that the North Carolina facility won't be doing any refining. It's just going to produce SC6, mainly from ore mined on site, but may supplement that with ore shipped in from other mines around the world. I'm noting this because while the majority will be US mined at the facility, some of the ore may still be shipped in from other countries, and that of course affects the overall carbon footprint of the lithium ore that will be processed in North Carolina. So with all of this SC6, what is Tesla going to do with it? SC6 is just a convenient way of delivering and transporting lithium. It's not the final version of lithium that's going to be used in battery production, which is why we also heard today that Tesla is reportedly about to build a lithium hydroxide refinery in Texas. It will turn the SC6 from the North Carolina facility into lithium hydroxide that can be used in the battery manufacturing process. At this point, though, you're probably wondering why Tesla isn't going straight to Nevada and working on building a mine there. And the answer, frankly, is time, money, and I suspect the lengthy processes involved. There are new projects coming online in Nevada that will eventually produce large volumes of lithium from the naturally occurring lithium-bearing clay in the state. To my knowledge, none are online yet and producing the quantities of lithium that Tesla needs for its future battery production. They also mostly are going to be using acid leaching processes to extract the lithium from the clay. During Battery Day, Tesla talked about a saline-based extraction method that it's been working on, but as some experts have warned, very few details during the day were given. This has led some to worry about how quickly Tesla might be able to start mining the 10,000 acres it's secured rights to mine in Nevada, and it also raises unanswered questions about how much water will be needed to carry out the extraction process, something that's already starting to worry cattle ranchers in the area, lest they start to have to compete with Tesla for water. Moreover, one federal permit for a lithium clay mine in Nevada has been in progress for more than a decade. In short, while Tesla's endgame may include Nevada, it may take a while to bring that facility online. The deal with Piedmont helps fill the gap nicely, and it will give Tesla approximately 8,000 metric tons of lithium hydroxide per year when both mine and refinery are online, which is expected to be sometime between July 2022 and July 2023. Because of the massive increase in demand for both electric vehicles and energy storage products, there's currently a higher demand for lithium hydroxide than there actually is supply. By setting up its own refinery and producing its own lithium hydroxide from SC6, remember, lithium hydroxide is used to make cathodes in Tesla's batteries, Tesla not only insulates itself from swings in market pricing, because it's negotiated a fixed price deal with Piedmont, but it also means that the lithium it uses comes from the US, and that means avoiding any sudden tariffs that may be levied due to political disagreements and differences of opinion between countries and their leaders. So there you have it. Tesla's new mining partner should, in a few years, make it possible for Tesla to have its own dedicated source of lithium, dramatically reduce shipping and processing costs, and help it lower the cost of batteries, as well as its carbon footprint. But there are many unanswered questions too, such as what the impact of lithium mining will have on the local environment in North Carolina, which I'd personally like to see answered. All mining makes a big impact on the planet, and I'm hopeful that whatever Tesla does, it and its suppliers will do their utmost to ensure that that impact is as small as possible. That's it for today's video. Thanks for joining me, and I'll see you next time.